right, we are going to finish up our notes on shifted conic sections. So we're in the same packet that we've been using. The front of it looks like this, so shifted conics. We're just on the last page, so we are sketching shifted hyperbola graphs. So to start off, we're going to write down our typical hyperbola equation and then our shifted hyperbola equation, which is on our formula sheet. So I do have my formula sheet here with me. The back of it is where we have hyperbolas and then shifted hyperbolas, and we're going to write down our equations here. So for a horizontal, it looks like this, but then once it's shifted, we have h and k, because h and k are our center. So I'm going to go ahead and write those down first. So we have x squared over a squared minus y squared over b squared. This is for a horizontal, and I know it's horizontal because my x squared is listed first. With hyperbolas, we have a subtraction in the middle, so whatever one is out in front kind of is our hint to if it's going to be horizontal or vertical. For a vertical one, we have y squared over a squared minus x squared over b squared. So I know this one is vertical because my y squared is in front. When we shift them, now I'm going to have x minus h inside parentheses being squared, and then y minus k. And then for this one, our k is always with our y. So since y is listed first, it needs to be with k. And then we have x minus h inside parentheses being squared. So we do have to pay attention to a lot of different things just to make sure that we're doing it right. One big thing on tests is make sure you can identify if it's going to be an ellipse or hyperbola first, so you know where to look at on your formula sheet. And you can look at if it says the word ellipse or hyperbola. You can look at if there's a subtraction in between. But usually I will tell you if it's an ellipse or hyperbola. So for example, when it says sketch the graph of that equation there, it is equal to 1. Sorry, I got really close to the next example there. So using my formula sheet, I don't know why I flipped it over, I'm on the back still. I'm actually going to compare it to the ones up here. So since we can see those, it's already equal to 1. And since my x is first and not my y, I know it looks like this. And we said that this one is horizontal. And that is on my formula sheet as well. So if I scoot this up here, my x is listed first, so it's in the horizontal column. So that's where I'm going to be looking when we are doing this problem. So I'm just going to slide this over so I can still kind of see it while I'm doing it. So we know it is horizontal. How has this hyperbola been shifted? So I'm looking at the number by my x. So right now it says x plus 1, but since our template is x minus h, that means it's a -1 technically. So I know it is going left 1. And then this number here tells me that I am going up 2. So I can find a, b, and c. So using my template, I know that a squared is underneath my x's. So 4 is a squared. So on my sheet here, I know a squared equals 4, which means if I want a by itself, I would have to take the square root of both sides, so I get normal a. Well, the square root of 4 is 2, so I know a is 2. B squared is the number that is underneath my y for this problem, so b squared is 9. So if I just want regular b, I have to take the square root of both sides. Well, the square root of 9 is 3. So I have a and b. So to figure out my c value, I am going to use this formula on my formula sheet. I have to use the one that is part of the hyperbola section. It will not work if you use the one from the ellipse section. So for a hyperbola, we have to use the one in the hyperbola section. So c squared equals a squared plus b squared. Now I have to pay attention to if I'm plugging in a or a squared. Since it is a squared, I have to plug in 4, not 2. 4 is a squared, and then 9 is b squared. So I know c squared is equal to 4 plus 9, which means my c squared is 13. So my normal c would be when I take the square root of both sides. So I would end up with the square root of 13, but I'm also going to figure out what that is as a decimal. So in my calculator, I'm going to do the square root of 13, and I get about 3.6. So I'm going to scoot my paper up a little bit so we can keep going. So now that we have A, B, and C, I'm going to go ahead and find all of my original things, and then I'll do the new stuff in a different color pen. So my original center is at 0, 0. I'm going to pause on the new center for now. My original vertices, I'm going to use my formula sheet. So I know it is plus or minus a comma 0. My A, we said was 2. So I'm going to do positive 2 comma 0 in the top blank, and then negative 2 comma 0 in the second blank. My foci are based on my C. We said C was the square root of 13, or about 3.6. So I'm going to use the decimal version. So 3.6 comma 0, and then I also need negative 3.6 comma 0 because we need to have the positive and the negative version according to our formula sheet. This right here, shifting our central box, we're going to talk about that when we actually sketch it out. And then we have our original asymptotes. So our asymptotes are at y equals the positive and the negative version of b over a times x. So I'm going to do y equals, my b was 3 and my a was 2, so I have 3 over 2x. And then I need the negative version, so y equals negative 3 over 2x. It's a small space, so I had to write small. So now I'm going to shift everything, and then for the asymptotes, I'm going to use my formula sheet to write those. So my new center, I am going to look back up at my equation, and I'm just going to scoot this down a little bit more. Since the 1 is next to the x, that goes in the x spot of my center, and the 2 is next to the y, that goes in the y spot for my center. And then remember, it's the opposite of what it looks. So x plus 1 would actually be a negative 1. And then this is minus 2, but we're going to do a positive 2. And that's because of the template. So we have our new center, which is negative 1 comma 2. So then just like with parabolas and ellipses, if we're going to find our new vertices, we're going to take our original and we're going to add our new center to it. So we add our x's, positive 2 plus negative 1 is positive 1, and then add our y's, 0 plus 2 is 2. Negative 2 plus negative 1 is negative 3. 0 plus 2 is 2. We'll do that with the foci as well. So 3.6 plus negative 1 is 2.6. 0 plus 2 is 2. Negative 3.6 plus negative 1 is negative 4.6. 0 plus 2 is 2. So I'm going to scoot it up so I can do my asymptotes. So I am going to write the equation, but I'm not going to graph the asymptotes by using these equations. I'm going to graph them using the box method, which goes back to this shifting my central box. So using my template here, I have y minus k. So I'm going to do y minus 2. Because k was 2, that was from our center, equals, I have plus or minus, so I'm going to keep doing the positive version since this was the positive version, b over a, so 3 over 2, that didn't change, and then I have x minus h, so x minus a negative 1, because I know my h is negative 1, would turn into a plus. And then For my second one, I have y minus k equals, this is my negative version, and then b over a, and then x minus h. X minus a negative 1 turns into x plus 1. So now I have enough information where I can go ahead and graph it. So I'm going to move my formula sheet. And I do have to scoot this up, so we might not be able to see a couple of things. I'll do my best. I want to still see my center, so we'll keep that at the top there. So I am going to do a coordinate plane here. I'm going to do 5 in all directions. So my new center, I'm going to graph everything in red. I have negative 1 comma 2, and I'm going to label that with the C. So that was my new center from up here. I plotted. My vertices, I have 1 comma 2, and then negative 3 comma 2. And then our foci, we have 2.6 comma 2 and negative 4.6 comma 2. All right, so I'm going to grab a different color here. Hopefully yellow will show up. So I need to do my asymptotes, and I'm going to do the box method because I don't feel like rearranging this into slope-intercept form. If I wanted to do that, I would have to distribute my fraction to both the x and the 1, and then get y by itself, so add 2 on both sides. And I would have to do that to both of them. So I just think the box method is easier for this. So to do that, we already have our vertices here, which is based on our a value. So this distance from my center out to my vertice is a distance of 2, because if I scoot back up here, we know that our a value was 2. So since I'm going horizontal 2, I have to go the opposite direction, so vertical, a distance of 3, since that is my b. So from my center, I'm going to go up 3 and put a little dot. And then I'm also going to go down 3 and put a dot. And then this will create my box. My scale's a little off, so I'm going to connect the dot from up here with my vertice, like that. And then I'm going to continue through that dot. And then, so I have a whole rectangle. Okay, so this length here was a distance of 2 because that's our A, and then this has a distance of 3, which is our B. So now I can draw my asymptotes, and then I can finish my hyperbola. So I'm going to keep doing it in yellow. So I'm going to grab my pad of paper here because I don't have a good ruler. And you can see that my rectangle is a little off since it doesn't quite go through the center, but that's okay. I do want to make sure that my asymptotes are going through the corners of my rectangle. And then to finish, we are going to plot our curves through our vertices, and we want to get as close as we can to our asymptote. So I am going to use blue so it stands out now. So through the vertice, pretty close to the asymptote here, and at the bottom. And then the same thing for the left side. So through the vertice on that side, get close to the asymptotes, and we are done with our hyperbola. So for example 2, I actually would like you to pause the video and try to find the characteristics that you feel comfortable finding, and then you can start the video and see if you get the same thing that I do. So for the one on the right here, for example, 2, I'm going to scoop my formula sheet on because since my y value is listed first, I know that vertical hyperbolas, the y value is also listed first. So I know this one is vertical, and that's going to help me figure out my characteristics. So I'm going to circle vertical. It has been shifted. Well, the 3 is by the y, so that's going up or down. So it's going up 3. And then nothing is being added on to my x, so it's not going left to right at all. So my a squared is, if I look back at my formula sheet, we're going to scoot that back in, is underneath my y right now. So that means my a squared is 36, which is this one. That means a is 6 because I take the square root of both sides. B squared is 16, which means B is 4 when I take the square root of both sides. So if I want to find my C value, I use the formula on my sheet and I plug in what I know. Well, I know A squared is 36 and B squared is 16. When I add those together, I get 52. So C squared equals 52. So that means C equals the square root of 52. Which the decimal version, I need to figure that out real quick, 7.21. So about 7.21. So my original center is at 0, 0. I'm going to come back to the new stuff. My original vertices are based on my A value. Now, since this one is a vertical hyperbola, my number has to go in my Y spot. So I have 0, comma, positive A, and my A was 6, and then 0, comma, negative A, or negative 6. My foci, it's still written as 0, comma, the positive and the negative version of my C. So 0, comma, positive 7.21, and then 0, comma, negative 7.21. And then for my original asymptotes, I have y equals positive a over b, so 6 over 4, and then y equals negative 6 over 4. 6 over 4 can be simplified as 3 over 2. Oh my goodness, you can't even see that. So you can leave it as 6 over 4, or you can simplify the fraction, that is fine. And how I got that is by using this equation here. So we knew our A was 6 and our B was 4. We plugged them in there and we have both the positive and the negative version. So now to find the new stuff, we're going to shift everything. So my new center, I'm going to scoop my paper back down so we can see our original equation. The number by my x is technically 0 because nothing is being added or subtracted. So it's going to be 0, comma, and then by my y is 3. Again, it's the opposite of what it looks. It looks like a minus. It is actually positive. So my new center is at 0, comma 3. So to find all my new stuff, I'm going to take my original and I'm going to add this to it. Add my x's, add my y's. So I get 0, comma 9 and 0, comma negative 3. 10.21 and negative 4.21 when I add those. And then my new asymptotes, I'm just going to, I'll scoot this all the way up so we can also sketch it. Use the template on my formula sheet, which is down here. So I have y minus 3 equals positive 6 over 4 x. My h was 0, so it's technically minus 0. So I guess I didn't even need those parentheses. And then I have the negative version. So negative 6 over 4 x. So I'm going to go ahead and sketch that out. I'm going to scoot it up a little bit further so I have enough room here. And I know since I shifted my graph upwards, I want to have a little bit more room at the top of my graph. All right, so I probably didn't have enough room at the bottom here, but that is okay. So I'm going to start by graphing my new center, which is off the screen, but you should have it on your paper. My new center is 0, 3, which is this. And then I have my new vertices, so 0, 9 and 0, -3. My foci, so 10.2-ish would be about there. And then my other one is actually off the paper, but I'm gonna say -4.21 is right at the bottom there. And this is gonna be my second foci. Definitely misjudged this. I should have done a scale of 2. That was my bad, but I'm going in pen. So now I know from my center to my first vertice, this distance is 1, 2, 3, 4, 5, 6. That matches my A value, which means I want to go opposite, so I want to go horizontal. My B value, which is 4. So I'm going to go out 4 to the right. I'm going to go out 4 to the left and put little dots. And that's how I'm going to make my box. So I want a line that goes through my vertices, and then it's going to come down through these dots here, which will create the sides. So now I can draw my asymptotes so I can make my hyperbola. So going through the corners of my rectangle, I'm going to do dotted lines for my asymptotes. So I have one of them there. And my second one there. So I'm getting really close to my writing, but that's okay. So for my hyperbola, through both vertices as close to the asymptotes as I can get. So here's the top curve. And then the bottom one is going to go off the paper, and that's okay. So it's going to go through the vertice, and it would continue to get close to the asymptote and curve, but since we're at the end of the paper, unfortunately, that is what it looks like. All right, so we're going to flip to the back, and on the back, we are not graphing anymore, but we are given some characteristics, and we need to write our equation for it. So for example 3, it says find an equation for the hyperbola with a center at 2, 4, foci at 2, 1 and 2, 7, and then vertices at 2, 6 and 2, 2. So I do want to label what I know. If I have my center, I automatically have my H and my K. And then since I'm given my foci and my vertices, I can use those to work backwards to find my original foci, which will give me my C, and my original vertices, which will give me my A. So to work backwards, what I want to do is take each point and I'm going to subtract the center from it. You can do it long ways. I am going to actually just write it underneath here. So I am going to subtract 2, 4. And so when I do that, well, 2 minus 2 is 0. 1 minus 4 is -3. I'm going to do it for this one as well. Subtract those. 2 minus 2 is 0. 7 minus 4 is 3. So my original foci are at 0, -3, and 0, +3. It makes sense that they're both 3's, one positive and one negative, because we know for our foci it has to be positive and negative c. So I'm going to do the same thing for my vertices. I'm going to subtract 2, 4, so I get 0, 2. And then over here I'm going to subtract 2, 4, and I get 0, -2. So I am going to label these right here were my original foci, which means C equals 3. And then this one and this one are my original vertices, which means A equals 2. So now to write our equation, we need to figure out our B, and then we'll have enough information. So I am going to use C squared equals A squared plus B squared, and I'm going to plug in what I know. I know C is 3, so I have 3 squared equals A is 2, so 2 squared plus B squared. 3 squared is 9, 2 squared is 4. And then when I subtract 4 on both sides, I get 5 equals B squared. So now, looking at how my original foci were written and my original vertices were written, I have 0, the number. So when I look at my formula sheet, I'm going to cover it up. The vertices that are written with the 0 first, and the foci written with the 0 first are part of the vertical side for my hyperbola. So I'm going to follow the template for a vertical hyperbola and plug in what I know. So I'm going to write that template on my paper. I'm going to do it down here. So I have y minus k over a squared minus x minus h squared over b squared equals 1. So now that we have everything labeled, we have y minus our k, which was 4, all over a squared. Well, if a is 2, 2 squared is 4. Then I have minus x minus my h was 2 from up here over b squared. Well, b squared is 5. I don't have to square that because b is already squared, so I have 5. And then it's equal to 1. And that is my equation. All right, the last one on this page, example 4. It says find an equation for the hyperbola with asymptotes at that, and then vertices at 0, -1, and 8, -1. So because I'm given the equations of my asymptotes, that actually tells me what my center is. So looking at my formula sheet, for either a horizontal or a vertical, it follows the same where k is always by y and h is always by x. And that's what I need for my center. So looking at my asymptotes, I know that this is my h and this is my k. So h is 4 and then k is -1 because it's y minus k, and that would be y minus a -1 would turn into a y plus 1. So over here I'm going to keep note my center is at 4, -1. So then, using my vertices and working backwards, I am going to subtract my center from those to get my original ones. So 0 minus 4 is -4, and then -1 minus a -1 is 0. And then I'm going to do it off to the side here. So my x is 8 minus 4 is +4, and then -1 minus -1 is 0. So my original vertices are written in red as 4, 0 and -4, 0. So that means I know that a is 4. That also tells me that this is going to be horizontal because For my original vertices, the numbers are written in the x spot, so I know my hyperbola is horizontal. So looking at my formula sheet again, for my asymptotes, I want to kind of include both. I know that this fraction, 3 over 4, is equal to b over a. So I'm going to put that down here. So 3 over 4 equals b over a. Now, I do know that this could be a simplified fraction, so maybe it's not 3 over 4, maybe it was originally like 9 over 12, or something like that. So if I know a is 4, I want to plug that in. So I have 3 over 4 equals b over 4. Well, if I can see that the 4 didn't change to something different, that means b has to be 3. If it was something different, we would cross multiply and then solve for b. But we don't need to for this one, so b is 3. Now I have enough to write my equation. So since I'm doing a horizontal hyperbola, I have x minus my h, which was 4. And that's going to be all over a squared. Since a was 4, 4 squared is 16. Then I have y minus k. Since k was a -1, it would turn into y plus 1, because when you subtract a negative, it turns to addition, over b squared. b is 3, so when you square it, you get 9, equals 1. And that is our equation.